Most modern engineering CAD systems use solid modeling technology. In this lecture, we'll briefly talk about the basics of solid modeling. SolidWorks was first introduced to the market around 1995, and it was the first engineering CAD system specifically run on personal computers with a Windows operating system. It is based on the boundary representation-based solid modeling system. It is a parametric, dimension-driven system, a feature-based and history-based system, and also a constraint-based system. These buzzwords will be all explained briefly in a moment. I think understanding these jargons will be helpful to be a better SolidWorks user. It is a design system. While designing a product, designers modify the design continuously. CAD systems must be easy to modify the designs, and any changes in parts, assemblies, or drawings must propagate to relevant parts, drawings, or assemblies automatically. So let's first think how we can represent a 3D object in computer. We need to have certain formats or data structure and algorithms for creating, modifying the models. And the models are displayed to the users in different ways, whether in graphics, text, or tabular formats. They also need to be stored and retrieved in and out of a database or computer storage such as hard drive or RAM. There are many ways of representing 3D objects: wireframes, surface modeling, solid modeling, mesh, and so on. We'll discuss very briefly on the basics of these representations. Wireframe models. A wireframe is one of the simplest representation you can think of. You can draw the outlines of the objects as lines or curves. For simple objects, you can quickly identify the objects by looking at the outlines only. Here are a few example primitives. As the objects get more complex, however, it'll look extremely complex and confusing. A more serious problem of the wireframe representation is the ambiguity due to its simplistic representation. Here's a well-known example. What do you see from this model? Some may see an object like this or like this. There are many more ways you may see. The problem is that all these different interpretations are all correct. So a wireframe representation is not unique and ambiguous. Another problem is that there is no way of checking the validity of the model. The validity means that the digital model can be actually realized in the real world and fabricated as a tangible object. Any non-realistic object can be made in wireframe, and the computer cannot check the validity. The next level is the surface modeling. In addition to the lines and curves, the surface information of the objects is added. The exteriors of the objects are represented by mathematical surfaces. Surface modeling is good for modeling complex freeform organic shapes. The surface means zero thickness, an ideal mathematical representation, which means that the model cannot be directly manufactured. The primary purpose of this model is to represent the exterior shapes. It is not a volumetric model, although surface visualize three-dimensional spatial shapes. Even if the surface is from a closed volume, the computer cannot easily tell if a particular point in a space belongs to the inside or outside of the object. Mesh models. In the mesh models, the surface of the model is approximated by polygons such as triangles. Computer graphics have used the mesh model in game software. In the engineering applications, the finite element analysis has been used the facet mesh models for a long time. Due to the popularity of 3D printing, the mesh model has become more important and widely used, especially the STL files. The STL, or stereolithography, is one of the most popular file formats. The STL format is very simple. It is composed of a series of triangles, and each triangle is represented by the positions of the three corner points and optionally its normal vector. There's no relationships between the triangles. This is called the soup of triangles. The model is an approximation, so it cannot be directly used for engineering applications that needs precise representations. Solid modeling is the technology that most modern CAD systems are based on. True volumetric 3D model can be represented by the solid modeling systems. This representation can build an object filled with material, and it can be manufactured, although the model is still a mathematical virtual model. SolidWorks is a solid modeling system. One of the most important distinctions is that the boundary representation of the object is fully described, and it clearly divides the inside of the object and the outer space. Hence, it can calculate the mass properties such as volume, the surface area, and moments of inertia, and so forth. Model validity can be checked to help designers detect non-manufactured parts or assemblies. There are many different ways of representing solid models, but the most popular one is what is called BREP, or Boundary Representation Method. In the BREP model, the boundary of the object is precisely represented within a certain tolerance. We'll not discuss any more details of these methods, but just remember the term BREP or boundary representation. That is the data structure used by most modern engineering CAD systems. The CAD systems serve as a central database so that models can be manufactured, analyzed, and simulated as virtual mock-up models.